everybody to have their pen and paper, please. Keep making notes. You are not special. You will not remember this forever. You will need to make notes. Now there will be some special friends who will borrow notebook from someone. How many don't have pen? Please tell me how many don't have pen? No pen, huh? Laptop you have? You can note on laptop also, no problem. You can make note. Anybody without pen and without laptop? Anybody here without pen and without laptop? I want to give Lifetime Achievement Award. That's why. Both pen and laptop. At least pen and you have pen and laptop. Very good. Both pen and laptop. Very good. Very good. You're college students, man. How you can go anywhere without notebook? Should carry pen with you all the time. I still carry pen. Just showing you. I'm still carrying pen with me. But my cap is gone somewhere. I don't know where it is. Okay. Pen, paper, notebook, everyone. Hello. It's not conference. You just take out your pen and paper. That's it. No discussion. No need for discussion. Okay. Today is going to be a complicated class. I'm telling you beforehand only. Okay. It's going to be complicated because we are going to do multiple steps together. We're going to do multiple steps together. This will be your first introduction into what we call data science. Okay. Can anybody tell me what do you think is data science? Don't tell me it is science of data. Okay. Tell me what do you think is data science? Bring some meaningful insights from the data. Very good. What else? Analysis. Okay. Anything else? How many people in data science branch? So you should know what your branch is about, no? What is data science? What is data science? Anybody? Get meaningful insights. Answer here. Get meaningful insights from data is number one. Number two, somebody said analysis. Okay. Very good. You're correct. Data science is getting the insights from the data. But when we talk about data science specifically, there are getting analysis or getting insights from the data using specific algorithms. Okay. So when we go into proper data science, we'll apply specific algorithms like linear regression, right? Logistic regression, multivariate regression, KNN, clustering. You've heard of these terms? Heard of them. You may not understand them, it's fine, but heard of them. Okay. So why we apply these algorithms? To get some insights from the data. Okay. Now to get to that level of applying algorithms, first we need to know some very basics of Python libraries. Two libraries that we are going to explore today and tomorrow. We are going to explore multiple libraries today and tomorrow, but two very, very important libraries are there. Can anybody tell me what those libraries are? NumPy, Pandas. Super. How many of you already familiar with NumPys? Okay, two students there. Anybody else familiar? Used NumPy anytime? Okay, few students. Pandas, anybody used Pandas for something? Alright. So we'll start from the very, very beginning, everyone. We're going to start from very beginning. Don't worry. If you've never used, we'll use it. But this is not like your generic Python where we have loops, then we have 2D loops, like nested loops, then lists, then 2D lists, where we are continuously incrementally doing. Here we are going to do 2-3 different topics and then combine them all together. Now today's purpose is going to be this actually. Can anybody guess what this is? It's a graph. Very good. What graph is this of? Can anybody guess? You may not guess, it's fine. But can anybody guess what does this graph look like? Mountain, yes. It looks like a mountain, okay. But what is this graph of? What do you think it is a graph of? Okay, let me see if I can move a little bit up. Let's see if you have here. Yeah. Bitcoin. Okay, anybody heard of Bitcoin before? Anybody heard Bitcoin? Okay, what is Bitcoin? Digital currency. Very good. Very good. Now, how Bitcoin works is not part of our class today. That's about cryptocurrency. Okay. But I want you to read about cryptocurrency. First homework is read. Today you just know it's digital currency. Tomorrow when you come to the session, I want you to tell me one line or two lines about what is cryptocurrency. Write it down, first homework. You will forget, and after 5 minutes you're going to forget, I know. So write it down. First homework is finding out what is cryptocurrency, how it works. Tomorrow if you tell me cryptocurrency is one that uses cryptography, then you should be able to explain what is cryptography. Don't use any word that you don't understand. Whatever word that you will use tomorrow to explain, you have to understand it. Okay? You are all saying digital currency. What is a currency? You should be able to explain what that is. Why I am being so strict? Because interviewer will also ask you like this. Okay? What is a cryptocurrency? You'll say it's digital currency. Okay, what do you mean by digital currency? What is the meaning of that? There you all will be blank. You should give the correct answer after that. Okay, so first homework is this. Now today's hackathon or today's session will not be about, we are not going to suddenly get thousands of Bitcoin. That's not going to happen. We are not going to become rich suddenly. Okay, it's going to be analysis of this cryptocurrency. Very specifically, this cryptocurrency has some value in rupees and some value in dollars. Just like any currency, you can convert from one currency to the other. For example, anybody knows how much it takes for $1 to 1 rupee today? 79 is gone 1 month back, that was. 81, I think it touched 82 also recently. So somewhere 81, 82, it crossed 80 mark, right? So it's becoming very strong, basically dollar. Now, any currency has a conversion rate from that own currency to a target currency. So the dollar, for example, if I convert to rupee, I take $1, I will approximately get 81 or 82 rupees. Okay. This graph that you see here is exactly that. It tells you one Bitcoin, if I convert into rupees, what is the price? Yes, 16.5. I think today it's 16.15 something, right? So we'll look at it. But that conversion is there. You'll get a certain price. Now, if you're going to get certain price, what's the graph here? Why do we have a graph here? So as somebody said, the price is this. This is the price. Today it's actually 16.17 lakhs. Depends on who you ask, but 16.17 lakh. So why this big graph? We can just say 16.17 lakh, right? 16.2 lakhs, let's say. Why this graph? Louder? Day-to-day prices. Very good. So this will tell you exactly, not even day-to-day, but time-to-time price. Because cryptocurrencies are generally volatile, meaning they keep changing their price again and again. So here on a day-to-day basis, so if you will not be able to see this, but here it says 1600. What is 1600 in time? 4 p.m. So at 4 p.m. today or yesterday, it was at some price. At 3 a.m. it was some price. There was some peak. At 5 a.m. there was some price today morning. Right? At 5 a.m. some big peak came. And today it's only increasing. At 1 p.m. it's higher than it was yesterday. So at every point it's increasing. Now this is the price that is there for today. This is 24 hours. If I look at, let's say, last 1 year, what has it been like? Okay. So if I look at last 1 year, it says 15th November, it was some 50 lakhs. 15th November, it was some 50 lakhs. And today it is at 17 October, some 15 lakhs. Okay. It's some 15 lakhs. So big reduction is there in the price, everyone. Yes, this all we are able to understand. The big reduction. Okay. Why am I talking about cryptocurrency? We are going to do analysis of this. We are going to do analysis of these prices. The task today will be, we are going to look at a website like this. This website is called CoinGecko. The website's name is called CoinGecko. You can also write it down. I'll write it here as well. It's called CoinGecko. All right, that's the name of the website. There are multiple websites. This is not the only one. There are multiple websites. But this is the website, CoinGecko.com. This website is having this graph. And what we are going to do is, we are going to directly query. Query meaning we are going to directly talk to CoinGecko, get the data from CoinGecko of a particular cryptocurrency from some date to some date, and do analysis. What's the analysis we are going to do? We are going to find out what's the average price, what is the median price, what is the standard deviation. These all terms, if you don't know, don't worry, I will explain. But we'll find out what's the standard deviation. In that price, in that date range, from starting date to ending date, in that date range, we will find out what was the minimum price and what's the maximum price. And all this we will do using NumPy. Okay. So that is our task for today. Sounds fun? Exciting? You want to do this? Right? Sounds like an interesting one. Now, once you learn how to do this, that is, once you learn how to get data from any website and do analysis, you can do this to any data. You can do it to any data. You can pick up movies. You can pick up cricket scores. You can pick up any sports scores. You can do any data and sit and do any analysis on that data. Okay? This is what a lot of data scientists do. They keep finding out interesting data sets, right? Very interesting data sets, and then they try to figure out any patterns in them, any analysis in them. Okay. Now, before we start, there is some basic maths we need to know. Some very, very basic maths we need to know. And the first thing we need to know is something called as mean. How many of you have heard of mean? What's the mean of a data set or mean of some numbers? Average. So how do you calculate the average? Sum of the numbers divided by number, like the amount of numbers or the number of numbers, right? So the number of sum of the elements divided by number of elements, right? So what would be the formula? Let's say mean will be equal to sum of, let's say, numbers divided by n, whereas n is the number of numbers. Okay, so that's mean. Okay, if I had to calculate the mean of this, you can all quickly calculate it. These are the numbers. Give me the mean of, there are 1, 2, 3, 4, 5, 6 4s, 2 8s and 120. Calculate it. Use your pen and paper. Don't do mental maths. Okay. 6 4s are 24 plus 16 is 40 plus 20 is 60. And how many elements are there here? 10 elements are there? Say, yeah, 10 elements, right? So it will be 60 divided by 10. 9 elements are there. Very nice. Okay. Which is equal to 6.66. Alright. 6.67, let's say. Right. I'll just round it off. Is that correct? Confirm, everyone? Okay. I'll also just confirm on maths because I don't trust your all maths. Okay, correct. Very good. Everybody, 6.67. All right. So that's mean. Let's look at median. What is median? Can anybody tell me? Okay, but what does median mean? The middlemost element of a sorted data set. Data set must be sorted. Okay. If it's not sorted, first you sort it and then you take the middlemost element. Okay. So here the middlemost element will be, there are 9 elements, which will be the 4th element over here. Correct? So what's the 4th element here? 1, 2, 3, 4. Sorry, 5th element rather, actually. So that will be 4. Right? So that's median here would be 4. Yeah, median would be 4. Okay. We'll come to standard deviation. You all know the formula of standard deviation? Remember, don't remember? Okay, we'll come to standard deviation in just a minute. Okay. But one thing is to know the formula of mean and median. The other thing is to understand the meaning of it. Okay. Now, mean and median are used to aggregate, or meaning it used to tell us some information about the data set that we have. Okay. Now, imagine all the numbers here are actually the packages of the students who have sat for placements. So let's say 9 students sat for placements, and there's a college, there are only 9 students, and all those 9 students sat for placement. 6 students got 4 LPA, 2 students got 8 LPA, 1 student got 20 LPA. Okay. How many of you with 20 LPA here? How many will be there for 20 LPA? Raise your hands, come on. Right? I'm sure many will get. You should have confidence at least that I will get. Right? Nobody will come back and check this recording. Hey, you said you will get, you didn't get. Nobody will say that, right? Have the confidence that you're going to get. Okay. Anyways, so what is that? What is the data set now? What did I say the data set is? Students, placement, packages. Okay. Now let's see, if I tell you, if the college comes to you and says, on average, we got a package of 6.7 LPA. Actually, it's correct. Average, they got 6.7 LPA. But it looks a little bit off, no? Because majority of students got less than 6.7. You're understanding this point? Majority of them got less than 6.7. Right? Majority of them got how much? Most of them got 4 LPA over here. But if you look at the package, if somebody is advertising, they're going to say 6.7 LPA. You get what I'm saying, everyone? So what mean is good for is if there is not so much variation in data. Why we got 6.7 here? Now imagine there are 100 students and let's say 90 students or let's say 50 students got 4 lakhs and the other ones got much higher. Let's say there is a 40 LPA also here. Only one student, or not even say 20. Let's say this is 40. Now what does the average become, everyone? This will become 80. Yeah, 80 by 9 will be 8.89. Again, yes. Okay, very nice. 8.89. If somebody got 40 LPA, then the entire average becomes 8.89. The average is literally double, more than double of this 4 LPA. Okay. Now, if you or if anybody is going to join this college, most likely what is the package they're going to get? Most likely what's the biggest probability they'll get? 4. But the average is 8.9, double. Okay. What it means, when you have a big variation, right? When you have 2-3 extreme values, it can skew or it can bias the mean. Okay. It can actually bias the mean. Like you can have a really big value sometime. Okay. How does this relate to us? If you look at this again, all right. If you take the average, right, of the price probably in this entire thing, and let's say it was like this might even dominate. This part might dominate the overall price because this is an extreme value, right? It's thrice. That's 15K right now, 15 lakhs, but this is thrice of that value. Okay, it's about 50 lakhs. So what does that mean for you? Not much. When you go and become a data scientist and when you're talking about data, you should always remember that mean is not to be relied on always. It depends on the data set. Meaning if there is 1 or 2 big exceptions, then there is a good chance that the mean will get influenced. The mean will be inaccurate, or rather mean is not a good representation of the data. Understanding this part, everyone? Did you all understand this? Yes or no? I want to hear. Okay. Now let's come to median. If that 20 does become 40, does the median change? Does the median change? No. So in a continuous sense, when you're talking in terms of a continuous sense of data, in a sorted data where you have like a continuous there, and you generally want to see what's the midpoint, like what's the part that's coming in the middle exactly. That time median is a good option. All right. So in the case of things like salaries, median is always a good option. In the case of prices, median is a good option. So because if you look at, let's say, the mobile prices, if we are all going to do mobile prices today, what's the most expensive mobile phone? iPhone 14. What's the price? What? 12 lakhs. 1,78,000, right? But most of the phones you will get in 5,000 to 40,000 range, right? If I wanted to check what's the price of a phone right now, if I take average, what will happen? iPhone 14 is going to inflate that average a lot, whereas that is just one phone, right? Whereas if I take the median price, what will end up happening? I will get a more accurate representation. Okay, that if I want to buy a phone, the median price is this. Do you get my point, everyone? Right? Okay. So how does that work here? Not really. In the case of our project, we are going to get both median as well as mean. But when you are going for any interview, when you are actually discussing about data science, make sure you tell this. Make sure you know this. What's the use of a mean? What's the use of a median? How it can be affected. Then on top of that, there is something called a standard deviation. What standard deviation? Does anybody know? What standard deviation? Anybody heard of it before? Yes, heard of it? Okay. See, standard deviation, first visualize what it's trying to achieve and then get the formula. Standard deviation, this is the formula, don't worry about that. Look at this. This is the heights of people. Okay, so assume that these are the heights of different people over here. Okay. What standard deviation tells you is, see, if you calculate the mean of everybody's height, means the average, you'll get this middle red line. You'll get this middle red line. What standard deviation tells you is, generally speaking, how further apart are people from the average. So what this is telling you is, this is the, do you see this dark red line, everyone? Yes or no? Okay. This dark red line is the mean. This is the average height. But again, are there any extreme values? This person is extreme, right? They're having a very tall value. And this person is also kind of extreme, very short height, right? There are extremes, but generally speaking, what is the deviation from the mean? What's the distance from the mean that you'll generally find of any item? Okay. And that is called the standard deviation, meaning this is the mean, this much variation you will get. That's the standard deviation. Means at a standard value, this is the deviation that you're going to end up getting. Now you'll say, but sir, we are getting, yes, you're getting here. This and this people are extremes. For the general case, you'll find most people within this range. Within this range. Plus minus this much of the mean. Plus minus this much of the mean is where you'll find most people. Why is this good? It tells you if the standard deviation is a lot, it means that the mean is there, but all the other values differ from the mean by a lot. There's a lot of deviation. So for example, if I take, let's say, everybody's height over here, right? There will be a certain average and you will all roughly be around that average. Nobody will be equal to the exact average, right? Yeah, just look around you. You'll not be equal to exact average, but somebody will be little bit above, little bit below. There will be one or two people who are much taller than that and one or two people who are much shorter than that. But generally speaking, you will be above and below the medium height. Okay, that's called that is a standard deviation, which is for things like height, where there's not much deviation. But if you look at something like a cryptocurrency, if you look at something like this, we'll come up with a standard deviation. The more there is deviation from the mean, it means more the currency is volatile. Mean that, let's say I take the average price is 10 rupees for this. Average price is 10 rupees. And standard deviation is 1 rupee. Meaning most of the days it will either be 9 rupee or 11 rupees. Most of the days it's going to be 9 rupee or 11 rupee. It's okay to invest maybe in it. Right? Because I put 10 rupee now, after 1 year also it might just be 10 rupee. But if the standard deviation itself is 8, standard deviation itself is 8. I put 10 rupee today, tomorrow it could be 2 or 18. Tomorrow it could be 2 or 18, plus minus of that. Meaning, it's a very volatile currency. It could be lesser, it could be more, it's constantly changing. Right? So, standard deviation tells you how volatile or how spread out the data is. Your heights are very close. Right? Anybody in your age bracket will have roughly the similar height, plus minus some inches. Okay? But if I take your height, let's say with 12th grade student, 8th grade student, 5th grade student, KG student, then it will be different. There will be a lot of deviation in the heights, right? So over there, standard deviation will be higher. Understanding this part, everyone, understanding meaning of these concepts so far, okay? How to calculate standard deviation is, you take each term, don't get scared by this, you'll take each term, minus it with the average, each term minus it with the average and square it. Take each term, minus it with the average and square it, and of that you will divide by n and take square root. Okay, it's basically the average of the differences from the mean, average of the squared differences from the mean and square root of that. Do write it down, super important. We'll calculate now standard deviation one by one. You must all be thinking, sir, data science, what is this? You're talking maths over here. Don't worry, data science is application of this maths. That's what data science is. You've written this? Write it now. Wrote it? Very good. Okay. Got this, everybody? All right. So, very quickly, can you calculate the standard deviation of this? Standard deviation of this. What was the mean, everybody, of this? I'll make this 40 just so we have it nicely. So, what was the mean of this? Is equal to 89, right? Just for the sake of it, take it like it's 9 only. Assume the mean is 9 only. Just for our calculation, everybody. Okay. So assume the mean is 9 only. If you have to calculate standard deviation here, what would it be? What will I do? I will take each number and subtract it from the mean and square the entire thing. So it's going to be 4 minus 9 square plus 4 minus 9 square plus 4 minus 9 square, right? Which is what? 4 minus 9 is 5 square will be 25. So 25 plus how many times will we have? Then 8 minus 9. So it will be 1 plus what is 40 minus 9? 31. So it should be 40 minus 9, right? Yeah, 40 and 31. 31 square. 961. Again. Okay, very nice. 961. All right. This entire thing has to be divided by 9, which is equal to, this will be 100, 150, 152 and 961. 1113, is that correct? Which is equal to 1113 divided by 9 is equal to, yeah, so I'll take it as 123.6 and we have to take square root of this, right? So what is the square root of this? $11. Okay, roughly 11 point something. All right, so that's the standard deviation here, which means it's high actually, right? Standard deviation is high over here. Okay, shall we go to the next one, everyone? Yes, so you understood the meaning of these three important statistics. There are many more statistics that are important. There are things like mode, variance, many more things. I'm not touching that right now. Okay, there will be many more as and when we are doing some algorithms, data science algorithms. That time we'll take them up for sure. Okay. All right. So now the next thing I want you to know, which every data scientist must do, is use this thing called as a requests library. There's something called as a requests library, and that's something that you should always know. Now, what that request library does is, you are able to get any data from anything called an API. Anybody heard of an API? What's an API? Application Program Interface. Very good. So let me see if I can pull that up for you all. All right. So application programming interface. Let me see if we get that. Okay, cool. So what generally happens, everyone, what ends up happening is that every system, okay, every system on the internet works with something like this, works with something called HTTP verbs. Anyone of you heard of this? Post, get, put, patch, delete. Anybody heard of this? Okay, some of you have, others never heard. All right, we don't have to go into all of them, but what you need to know is, as soon as, whenever you type, for example, app.edist.com, whenever you're going to Edist website also, okay, what you're actually doing is you're reaching out to the Edist server. That Edist server, all good? Okay, so that Edist server is going to give some data to you, to this Chrome browser, and then that Chrome browser displays that data in some way. Happens with everything. When you do Google search, when you go to Instagram, in all of these cases, there's a server over there, and the server gives you some data. Okay. Now, in many cases, you can submit data also. For example, when you do coding questions, what happens in coding question? You don't just get the data, right? You write a coding question, you write a solution, and then submit that data. Correct? That is what we call as a post, right? Where you submit a data, generally you do a post. Now, there are other verbs also. You can read it when it's over here. Generally, anything on the internet will communicate with each other using APIs. Now, if I want to take some information, I use a GET request or a GET API. That will give me some information. And if I want to submit some information, I do something called as a POST API. Now, what we want to do is, we want to get information from whom? We want to get information from CoinGecko. Okay, we are going to get some information from CoinGecko. And as you can see, CoinGecko gives us a bunch of different methods of getting it. So for example, if you do get/ping, right, where is the get/ping? It will be on coingecko.com/ this thing ping. When you do this, you will get the status of, is the CoinGecko server working or not working. Okay, like that. It has many different methods. Another way of thinking of it is like a function. You all written Python functions? It's like a function, but on the server, on the website. So we are going to use the CoinGecko API to get some of the prices into our system. Okay. Many websites are there that give this API, that give you information. What are the kind of other websites? There's a Marvel API. You have heard of Marvel? Yes or no? MCU, Marvel, you all heard, right? So there's a Marvel API. There's a Pokemon API. They'll give you all of the information about any Pokemon that you want. You want to check Pikachu, what does it evolve into? It will give you that information. Marvel, how many types of Spider-Man are there? I don't know, 3, 4, right? Miles Morales, Peter Parker. It gives you all that information, right? Who is who? How many types of Hulk are there? How many types of Thor are there? When was Thor's first comic? There is Flights API. There is a Train API. If you want to check train from one place to the other. There are many APIs that give you information about the world. If you are familiar with APIs, you can write really brilliant programs, really good projects. So please make sure you note this, because we will do 1 or 2 projects. Extra projects you can do on your own if you know how to use APIs properly. Okay. Now, the other thing is, when systems communicate with each other, there needs to be a common format, a common language. Okay. For example, if I start speaking to you right now in, let's say, Chinese, will you all understand? No, you're not going to understand, right? Because you don't understand Chinese, right? Same way, every system, when they talk to each other, they need to follow a certain format. On the internet, the format everybody is agreed on is called the, can anybody tell me which format? No, not binary. There is a certain format in which all the get and the post data is put in. Anybody knows that format? Okay, write it down. That format is called JSON. JSON. You might have heard of it. JSON. Full form of JSON is JavaScript Object Notation. JavaScript Object Notation. Yeah. So for example, that notation is going to look something like this. Right? Let's say you queried somewhere, it gives you some data. Now that data can be in any format, right? If it's in any format, we can't understand. But if it's in JSON format, which is what everybody has agreed to, everybody on the internet has agreed that we are going to use something called JSON, JSON, JavaScript Object Notation. This is the one. This entire reading material, everything, you will get it. As soon as you log in on Edis today, you will all have this. Don't worry about that. Does this, especially special coding, does this look familiar? What does this data type look like? Louder? Dictionary. Very good. You use dictionary, right? We will cover that in your classes, but this is what looks like a dictionary. What's a dictionary? Key, keys and values, key value pair. So JSON is nothing but a key value pair data type, meaning there will be keys. For example, this key is first name. So what this does is it tells you that this is the key. The value of the first name is Jim. This is the key last name. The value is Halpert, right? Anybody knows Jim Halpert, by the way? Second homework for you. Find out who is Jim Halpert. Okay, second homework. Okay. So departments are there. Now this departments, what is this? What does this look like? Yeah, this is multiple values. What does this look like? Louder? List. Okay. So the key is always a string usually. The key can be integer also. The key is usually a string or an integer, but the value can be string. It can be list. It can be integer. Okay. It can be a dictionary again in itself. Okay. You can have another dictionary in itself. Okay. We'll do much more of this when you do advanced data structures, when we do dictionaries. That's at the end of your Python course. But this is a JSON object. This is not a Python dictionary. This is a JSON object. But JSON and Python dictionary is almost similar. Like they're very, very same. So whenever you are working with any internet applications, you take that JSON object and you convert it to a Python dictionary. It converts to a Python dictionary over here. 2-3 other properties about dictionary. The key has to be unique always. Meaning I cannot have two first names. If I have a first name, I have a first name only. Think of it like your roll number. Do you all have two roll numbers? Everybody has one roll number. So there is no point having two keys. Yes, values may be similar. Values might be same. Okay. Can you give me an example of that? Maybe age is there and marks are there. Maybe your age is 20, your marks might also be 20. Correct? So age and marks, keys are different, but value might be same. Okay, so value uniqueness, there is no need for that. Okay, all right. So this is what a JSON object looks like. Right? It is keys which has some values. Now let's look at the key and value of the API that we want to use. All right. So there are many APIs. Like you go through this, there are thousands of APIs. We don't want to get into that. This is what financial analysts use. We are not getting into that. We'll do a very simple thing where we will get, okay. Here we go. All right. What this is requiring is, okay, let's take a easier one. Hold on. Okay. So what this one requires is, if you look at this, this is get coins ID /coin/ID. What it's saying is, if you ask CoinGecko for a particular coin/ID, the ID over here is, let's say Bitcoin. Okay. So the ID is Bitcoin. Let's say we do this, and all of these are, optional. So I'm going to leave them. They're all optional. We don't need them. You'll get a certain response and it tells you what response you're getting. Okay. It tells you response. Another homework for all of you is this code. There's something called HTTP status codes. HTTP status codes. Another homework. Read about HTTP status codes. When you get 200, it means okay. The moment you get 200, it means okay. Means execution was fine, everything is okay. Alright. Many of you might have got on Edis platform 404. Anybody got 404 not found? 404 is the internet's vocabulary or language for saying not found. 404 means not found, right? So that's that one. 403 is not authorized. Maybe it is there, but you are not authorized to take that. So that's a 403. Like that, there are many different error codes. Please look into it. So this first things first is 200 here means that it's okay, executed properly. Now here you get all of the different keys. What's the keys you get? You get, okay, you checked for ID Bitcoin. It's that symbol is BTC. The symbol here is BTC. The name of it is Bitcoin and so on. So you get many different properties over here of Bitcoin as such. You get a description also. What is it? Bitcoin is the first successful internet money based and so on. Right? So it gives a whole description over here. So a lot of information comes from that. What is this? This is a JSON object. JSON object which is having a lot keys and values over there. Okay. Now let's actually come into Python over here. Okay. We'll come into Python, and to do this, what I'm going to do is I'm going to execute. Anybody has heard of Jupyter Notebook? You all have to use Jupyter Notebook. I'll not use Jupyter Notebook. I'll use Google Colab. Heard of Google Colab, everyone? Everybody can go to it. You can just, all you need to do is do colab.research.com. You need to go to colab.research.com. Sorry, colab.research.google.com. Or you just Google for Google Colab. With your simple Google ID, you will get this. Okay. Good thing about this is you don't need to install anything. Everything will be on the browser. Now, let's start. If I did import requests, this is to import the requests library. Python has a very good request library. What it will do is it will take care of anything to do with APIs. Just delete that. Yeah. So I first run that. Now what I'm going to do is I'll say, okay, you know what? Data is equal to requests.get, and I'll go to that API that was there. That is this one. It gives you the URL also. This is the URL. If you went to this URL, you will get all of Bitcoin's detail. Okay. So I'll say like this, request.get. Okay. Now what this will do is this body that I got here, this response body, which is a JSON, I will end up getting it in my data over here. Let me show you. So this would have got it, and when I do data, you will see that you will just get a 200. What does 200 mean? HTTP code. It's okay. Right? It means it's okay. We got everything. This is a data object. So this is a response object. Response of 200. Now, if I did data.json, it will give me the entire JSON body. It's going to give me the entire JSON body of what all we fetched. Does it make sense, everyone? This is the JSON body, but this is a dictionary. You're getting a dictionary over here. Okay, so this is the entire dictionary. Now, what I want to do is I specifically want to know, let's say, for example, hold on, I think because this body is looking slightly different. Hold on. Yeah, no, it's there. Everything is there. Let's target. Hold on. Okay. Oh yeah, that's a very big one. Hold on. Yeah, here is all the data. It's a huge data, by the way. Here you go. Yeah, these are all the data that we've got. So for example, I just want to know what's the name of this. If I just want to know what is the name of this, we know it's Bitcoin, but I just want to know the name of it. Okay. Or I want to know its hashing algorithm. It has some hashing algorithm here. What I simply do is, this is the dictionary. Okay. I'll say, okay, of that dictionary, get me the key. Get me the key. Which is the key? I want to know, let's say, the hashing algorithm. What is hashing algorithm? We don't need to care right now. But I'm just saying that's the data that's given to us. So I'll say, you know what? Get me the hashing algorithm of this. Get me that key. The moment you do that, you end up getting that SHA-256 is the hashing algorithm. So the entire object was there. It had many keys in it. I want to get one specific key of that. What did I do? I gave the name of that key. I gave the name of that key. If I want to know all the keys, I can actually say .json dot keys. It will give me all the keys, and these are all the keys of it. Okay, so you get the ID, you get the symbol, you get the name, you get platforms, you get all of the different things. Okay, let's see about the price. There should be a price somewhere over here. One second. There ideally should be, or we need a target. Like we need to target it to rupees or dollars. Then only it gives a price. But there is something called country origin, where this Bitcoin is from. So let's try to go for that. Country origin. Okay, so there is no country origin. We don't know which country it started from. Okay, but I believe if you get some other one, let's say Ethereum. Anybody heard of Ethereum? Yeah. So let's run it for Ethereum here, and let's say Ethereum's country of origin. Okay, that also we don't know. It didn't start from a particular country. I guess USDC should be one. All right. Okay, no, that's not USDC. All right, fair enough. So we'll come up with another one. But yeah. Okay. So this is how you do get, by the way, everyone. So this is how you do a simple get. Now the get that we are going to do, is not this API, but we'll use another API. We'll use this one, market chart / range. The purpose of this API, always read it. There's a good documentation. Get historical data, which include price, market capitalization, and a bunch of other stuff. We don't need to know all of that. What it is going to give us is, if you tell me which cryptocurrency, which is the one we want to check. Let's say we want to check Bitcoin. I want to check Bitcoin. If you tell me which cryptocurrency versus which currency, against whom are we checking, everybody? Not Ethereum. What's the first thing? What's the graph I showed you? Bitcoin versus, what was the price in? Was it dollars? In rupees, Indian rupees. Okay. So I'll do it in INR. INR is Indian rupees. Now this is asking from which date to which date do you want it? From which date to which date? So let's say I want it from 1st of January of this year, 1st January 2022 to what is the date today? 18 October 2022. Now again, we have another problem here. What's the problem? They want it in a particular date format. What's the date format? The date format is called Unix timestamp. Anybody heard of this? Unix timestamp? Yes, no? Okay. Simply put, what computers do is, date formats are very difficult. You can say October 15, 15 October, 15 Oct 22, 15 Oct 2022, 15th October 2022, Tuesday 15 Oct 20. So bunch of different ways you can say the same thing, correct? And if you go to the American system, they do it the different way. They put the month first and then they put the day, right? So what computers have to do is, they have to keep a standard way. Just like how JSON is a standard way, dates also have to be standardized. Okay. So now don't get confused, don't get lost here. What are we talking about overall? I'm talking about the request library. In request library, we are doing the get method. We are doing get method. Why are we doing the get method? To get what? To get the data of Bitcoin. Very good. Bitcoin in rupees from some date to another date. We said we want from which date to which date? Jan 1st to 18th October here. So we want it in these two dates. Okay. But I can't just say Jan 1st. I need it in a particular format. That format is called as the Unix timestamp. Another homework, find out what is Unix timestamp. What does 0 in Unix timestamp mean? What is like 0? For us, what is the 0th year? What is the first year? Anybody knows? What is our year right now? What's the year right now? Come on. 2022. What is year 1? When is it year 1 and when does it become year 1 BC? Right? Find that out also, how that works. Okay. Alright. So, anyway, how do we get the Unix timestamp? Python has a way of getting the Unix timestamp. We'll come to that. For now, let's do a very, very simple thing. Okay. Let's just go to, let's say, Unix timestamp converter online. Okay. There are online websites that help you with this. You can very simply put it. So what's our first date that we wanted, everyone? So 2022, month is 1, day is 1. Okay. And we'll keep all of it to 0 over here. 0, 0, 0. And GMT. What is GMT? GMT is Greenwich Meridian Time. It's London time. Okay. We take that as the 0 time. There is no time difference there. Everything plus minus comes after that. Okay. Let's convert it to a timestamp. We need probably 0, 1. 0, 1 here, I guess. Is it because of the 0, 0? Invalid hour. Okay. 0, 0. Okay. Hold on. Let's make it 12 a.m. Okay. All right. 12 a.m. is the same thing. So we got this timestamp here. This is the timestamp that is needed. For that, it does the conversion and it got this timestamp. Okay. So I'll say from this timestamp to what is the date today, everyone? 18. So month will be 10 and this will be 18. Sorry. This is, did it change? One sec. Is it the same thing? Yeah, it changed, right? Okay. So it changed here. Now if I execute this, it will give me all of the prices from 1st January to 18th October. And if I go down here, it's actually giving me prices and a list of them. Prices and the list. Are you getting it? Now in that list, we have two things, right? And the other issue we also have is the target. Did we give a target over here? Yeah, we did. Okay, that's fine. Okay. So you're getting two things here. Somewhere at the start of the year, it was, I don't know if you can see, it was some 34 lakhs. Okay. Start of the year, it was some 34 lakhs. And now over here, probably it's some 16.6 lakhs. Okay. Sorry, it's some 19.4 lakhs it's saying here. Okay. Why it's saying, how it's saying, it's a separate thing. But you see also another thing here. 16409952001641108, this one, right? This is most likely what is called as the market cap. Market cap, meaning it's not the price, it is sum of all the Bitcoin in the world. Sum of all the Bitcoin in the world, how much, what would be the price of it in rupees? That's called the market cap. That we can ignore. We don't want that right now. All we want is this. All we want is the price over here. Okay. Now, what is important for us to see is this part. How does the request URL get generated? The request URL is like this. This is the CoinGecko API v3 coins. This /Bitcoin tells us which cryptocurrency we are looking for. Okay. As part of our project, we'll do analysis for multiple cryptocurrencies. So I'll just take this here so that you all can see. Okay. Everybody is able to see this? Yeah. I'll just take this even below. They're all on the same line. Don't worry about that. They're all on the same line. Okay. But I'm just putting in separate lines so we all understand. This, the first line is the actual API URL. This is what you're supposed to hit with. Slash Bitcoin means we want Bitcoin's value. If you put Ethereum here, it will give you Ethereum's value. Okay. We want the market chart. This is again, this is part of the API. Range, sorry, market chart slash range is part of the same thing. This is part of the API. Okay. Now it comes versus currency. Versus currency. Against which currency we want? Against INR. From this timestamp to this timestamp. So to make our API customizable, these are the different values we will take input. We will take this as input, Bitcoin, Ethereum, Litecoin, Dogecoin, whatever. We'll keep changing that. We'll keep changing this to which currency you want to make it, or we'll keep it INR only. And this part, the from and to, will be changeable all the time. From and to are going to be changeable. How will we do it? Let's have a quick look here. If I do it, instead of doing request.get, this is the earlier API. Let me take this API here. Right? This is the entire API. It's quite big. So one second. Let's do it another way. I'll say URL is equal to this entire big thing. Okay. Sorry. This thing. This one I'm going to substitute with the cryptocurrency name. So I'll put currency over here. And I'll use F strings. Do you all remember F strings? Yes. So I'm going to use currency over here. Okay. I'm going to put against INR only. There is a from timestamp. So I'll say start Unix to end Unix. Alright. So this is my URL. Now for that, I need to say currency equal to, right now it's Bitcoin. Okay. The start underscore Unix is equal to, we had that here, right? We calculated. This is the start part. End Unix is equal to this. Okay. That's the URL. And then what we'll do is, now we'll do data equals to requests dot get URL. Get this URL. Okay. Let's run this. Some data has come over there. We'll okay. So I'll just do data.json over here. Right? You get all of these different things. You get the prices, which are the market cap, as well as the prices. Okay. It's not just prices, by the way. Always a good thing to do is, once you do JSON, try to figure out what are the keys that you're going to get. You do dot keys. You'll come to know that it's giving you, let's say, prices. It's giving us market caps also separately. It's giving us total volumes also separately. So there are three things. We care only about the prices part. We are only caring about the prices part. In fact, I believe this is most likely the date. It's actually the date in Unix timestamp. Okay, that's why it's showing this. Anyways, we want the second part of that. So you got prices, this. What I'll do is, I'll just want the prices. So I'll take prices like this, and hold on, not dot prices, just prices here like that. Right. So I got the whole prices array over here, or the prices list. Okay. Again, even in that prices list, the first, this is a list of lists. This is a 2D list. Okay. This is an outer list, and then inside it, each item is the price for that day. There is a date as well as a price for that day. Date and a price for that day. Okay. That's what you're getting at every time. We don't care about that date. I just want the price because I want to calculate mean, median, and all those things on the price. Okay. So it's a list of lists that we have over here. Understood all the steps so far, everyone? Okay. Can you quickly write this down? The steps we took. So just recapping again, what if I had to break this down into different parts? Okay. RRR movie you saw? RRR, in that first part, second part, third part comes during the movie, right? Like that only. There are parts here. First things first, what we discussed, everybody, so far. First thing that we discussed was statistics, which was mean, median, standard deviation. Why is that important? We talked about the importance of each statistic, and we'll come to the analysis of that. Second thing then we saw was requests, right? Specifically, what is API? Application Programming Interface. Why is API? API gives you the method of two systems talking. It can be any systems, and everything has an API, by the way. This mouse has an API. You will not believe it, but mouse has an API because this is a wireless mouse. It has to connect with this laptop. Okay. This projector has an API. I'm not kidding you. I mean, it's not always through request library. There are other ways also, but it gives you the specification on how to talk to that system. Okay. When you go to, what's a simple example to give you all? Let's look at the switches. Okay. How to use the switches? You have to press one, it goes off. The other way it goes on, right? Did anybody tell you this? Through experience you learned, right? That this is on, this is off, correct? Same thing with APIs. What happens is it gives you methods to interact with that system. Now that system might have multiple ways of interaction, and that's what we have in an API. API has many verbs. What is the verb we were using? The HTTP verb we were using? Get. It's called a verb. It's called an HTTP verb. We are using the get verb. The data comes in which format? Which format? JSON format, which we convert into Python dictionary. So JSON format is the one you get, which is full form of JSON is everyone? JavaScript, object, notation. Super. Okay. So you have JSON, which is the standard. Very back in the day, probably in the 1990s or early 2000s, you used to use something called XML. This won't even, this won't even come in your interviews. It's that old, but I'm just telling you, it was not always JSON. It also used to be XML at one point, but now it's JSON. Everybody uses JSON right now. Okay. And every language that you develop with has a library for JSON. Okay. There is a Python library for JSON also. We are not using it because we don't need to do a lot of JSON right now. That .json gives us a dictionary directly. But when you want to post, when you want to submit details, that time you need to convert your dictionary to a JSON and then submit. So that conversion can happen through the JSON library. Okay, clear everyone? So far, following along what's happened? What we did then was, we said we want to have the historical price data of a cryptocurrency from one date to another date. When we went to do that, we found another hurdle, right? Another roadblock. What is the roadblock? What's the roadblock? The dates. Dates format is Unix timestamp. I can't just say 20 October, 9 October. I can't say that. It has to be a particular Unix timestamp. So we put a Unix timestamp over there. We converted it online. Okay. Now Python has a way of converting it. You can give a date and it will convert. Python has a particular way of doing that, and we'll see that as well. Okay. Alright. So far these are all the things we've done. Another second chapter close. Now third chapter we have to open. Okay. Till here everybody understood? Right. Pause here. Next what we're going to look at is NumPy. How does NumPy come into all of this? We'll look into that. Okay. So what I'll do is I'll give you all 5 minutes break. Talking about NumPy. NumPy and Pandas both are Python based. They end up using Python. Okay. But underlying they use a lot of C. They actually compile down to C, and C is super fast. So that's why we end up preferring to use things like NumPy and Pandas. Now, interestingly, all the loops and everything that we learned, we never actually apply on NumPy. We never try to use loops and all on NumPy. I'll tell you the reasons for that. Okay. Let's look at simple NumPy. NumPy, the most basic thing that you're going to use NumPy is NumPy arrays. Okay. It's called NumPy arrays. Generally, the convention is to import NumPy as NP. That's the convention. Now you might say that NumPy can be imported as NC, NV. That's up to you, right? But ideally, the convention, most people import it as NP. This is a library. You import that, import NumPy as NP. And the most important thing in NumPy is the arrays. So for example, I have a list, right? And the list is probably of, let's say, placements only. Okay. So placements is equal to, let's say, what was the list that we had? We had 6 4s, right? 2 8s and 40, right? So this is a list. This is a normal Python list. We've all used Python lists before, right? Now, what you do in NumPy is you say, let's say something like, data is equal to np dot array of placement. So you take a particular list that exists already and you generate from that. So now this is an np array. Now, again, the normal stuff resumes here. If I did, let's say, len of data, I'll get 9. This is normal data. Even though it's an np array, you can still apply len to it, okay? But it gives us a lot more advantages. This array, np array, gives us a lot many more things compared to the normal list, okay? One of it is it's much faster. Once it's converted to an np array, it's much faster. Because why? It uses C underneath. One drawback is list we can dynamically increase. We can keep doing dot append. In arrays, you can't do that. Once it's created, it's created. It's a particular size only. Okay, it can't go further than that. Now again, here also, it's the same thing. If I did, let's say, data of 1, right? What will I end up getting? 4, right? And data of -1, what should I get? 40. So it's the same thing as a list again. Same thing as a list, but it has some more features alongside it. Okay. For example, you can do something like data dot mean. This will give you the mean of this entire data set, which comes up to 8.888, which is what we all got, right? You can also get the median. You don't do data dot median, you do np dot median of data. Okay. So you do np dot median of data. It will give you that 4 is the median value of this. Okay. And then we can also do np dot sd of data. I believe it's sd or is std. One second. No. I believe it's std. Yeah. Right. So we got something 11, right? At that time. 11.1 or something. That's the standard deviation for this. Okay. So NumPy arrays come with all of these things. So you don't have to write a function here. You will not have to end up writing a particular function for finding the mean. That is sum of n divided by. You'll not have to do that. It automatically comes with mean. Automatically comes with median. Automatically comes with standard deviation. Okay. And pandas comes with even many more these things, which we'll cover tomorrow about pandas as well. Okay. Now another interesting thing is you can also do things like 2D arrays. You can also do 2D arrays. So for example, you had something like this only. There are many different sections, let's say. So this is the first section's placements. We'll reduce it, let's say. 4, 1, let's say 7, 9, 12, 30, and some. Just random numbers I'm taking. Okay. This is, let's say, I'll convert this to an NP array directly, and I'll say data is equal to NP dot array of this 2D list. Okay, it's a 2D list, and I get that. Now, when I do data dot shape, I will get 4, 3. What does this 4, 3 mean? It's a 4 rows, 3 columns. Okay. Dot shape, again, as a data scientist, one of the first things you'll do is anytime you get an NP array or anything, you'll do a dot shape just to find out what are the dimensions. Okay. Do note it down. Dot shape is super important. Even when you do AI, even when you do ML, TensorFlow, all of that, one of the first things you end up doing is dot shape just to figure out what are all the dimensions of this data type. Okay, so this gives us 4 rows and 3 columns. Now, if I just if you remember, sorry, this is data.shape. If you remember your lists, if I 1 second, let's add some more. Okay, now if you remember your lists, do you remember if I want to just get the first column, the 0th column, how do I get the 0th column? Sorry, 0th row. How do I get the 0th row? Data of 0 will give me the row, the entire row, right? So if I do data of 0, it will give me the entire row 417. And if I want to get the 7 number, how do I do it? Data of 0 of either -1 or 2. Both will work out well for me. I'll end up getting 7 because that's first row, last column. If I want to get this 15, what do I do? Not 1 comma. This is 0. There will be 1. 2 comma 1. Very nice. 2 comma 1. Okay. So that will end up giving me 15. Okay. Now, if I wanted the whole first row, I said I will do, or if I want the whole third row, I will do data 2 comma, or just data 2. It will give me the entire first row. Now, how do I get, using lists, one column? Was there any way of just selecting the column? Let me just put this here. Okay. Was there any way of just selecting, let's say I want the middle column. The middle column here is 1, 12, 15, 9. This is the middle column. Is there any way of selecting just the middle column using lists? Using lists? No. We'll have to end up writing a for loop. If you remember, this is a question also on a dist platform. You write a for loop, you go row by row, and you only select that particular column. In NumPy, you can actually select a particular column. Okay. The way that goes is, you will say, let's say this is data. Okay. I want to select the middle column. The column index is, what will be the column index if I want to select the middle column? What's the first column? 0. Next column is 1. So the 1 is the index. What you'll say is, select all the rows. So you'll put a colon over there. Select all the rows and give me the first column. Select all the rows and give me the first column. What it will do is, it will give you a new NumPy array just of the entire 1th column. Entire 1 column. Okay. It's very useful to us. Okay. What it did was, it took this 1, 12, 15, 9 and converted to another NumPy array and gave that to us. Okay. So this helps us in many ways. For example, in each, let's say the middle row, you wanted to find the mean. You can say this data for this particular row and you'll do mean over here. So now it will get you the mean of 1, 12, 15 and 9, which is 9.25. You can get column wise mean. Make sense, everyone? Okay. Now, other thing is, in a 1D array, do you want to write this down? Write it down, please, everyone. Right? I'm zooming in as much as possible. So sorry if it's not visible, but I'm trying to zoom in as much as possible over here. Okay. Now, if I just go back to my 2D array over here, if I go to my 2D array, what's the shape of it? What's the shape? 4, 3, meaning 4 rows, 3 columns. Very nice. Now, if I did the whole data dot mean, if I did whole data dot mean, what is it going to do? It will take the mean of all of the values over there. Okay. Meaning it doesn't care that they are in like different rows. It's going to take all the values and get the mean of them. Okay, everyone? But if I wanted it to be row wise, meaning give me the mean of 4, 1 and 7, then give me the mean of 9, 12 and 30, then give me the mean. How many such means I will get if I am doing row wise? 4 means. If I do it row wise, I'll get 4 means. If I'm doing column wise, that for each column give me, how many will I get? 3 means. Very good. Okay. Now we can actually tell NumPy along which axis it should be taking the mean. If I put over here, let's say axis equals to 0, it will tell you how many means did it give you? 1 second. It should have. Yeah, I'm not sure what that is. 1 second. And if I do, yeah, okay. So if I did axis is equal to 0 over here, what it's giving me? It's giving the mean along the, so it's what it's, okay, I'll tell you what this means. Don't worry. It's taking the column over here. Why did it do that? When you say 0, okay, when I did data.shape, what is the 0th one? 4. What it's saying is iterate over these 4, meaning 4, 9, 10, 1. Iterate like this and get me the mean. Then for this, iterate like this and get me the mean. Iterate like this and get me the mean. So what it is doing, it is giving me column wise mean by iterating over the rows. If you want to take the mean of a column, you need to iterate over the rows. So when I say axis equals to 0, what am I saying? Iterate over the rows. If I want to iterate over the column, which axis? I'll go along this axis. So if I want row wise mean, I need to iterate like this. So I'll say axis equals to 1, let's say. If I said axis equals to 1, then it's going to give me 4 means. Why? For each row it's finding it. 4, 1, 7, which will be what? 12 divided by 3 will give me 4. So I got that 4 over here, right? 9, 12, 30, which would be what? 21, 31, 21, 51 divided by 3 will give me 17, exactly, right? And so on, 10, 15, 25, 29 by 3 will give me some 9.6 and 10 by 0 will give me some 3.33, right? So axis is also super important. Axis 0 means rows, but it means I will iterate along those rows. Doesn't mean it's going to give me the mean of the rows. It means I'll go along the rows to calculate the mean. When axis is 1, I'm going to go along the columns to get the means. Okay. So remember this in your head always. Okay. For a NumPy. That's all the basic NumPy that we need to know to do our very, very basic project over here. Okay. To do our super basic project here. That's the maximum I need to know. Alright. So this is the URL that we formed, everyone, earlier. Okay. This is the start, this is the end, this is the URL. We got it, we got this prices. If I again replay the prices over here, what do we get? 1 second. Sorry, first let me just get this. And yeah. So I got the prices, which is a list. Now I need to do 5 things, everybody. I need to do 5 things. This is the actual project. The 5 things are: number 1, find the mean of all the prices. Number 2, find the median of all the prices. Number 3, find the standard deviation of all the prices. Number 4, find the maximum price. Number 5, find the minimum price. You can do all of this without NumPy. You can use a simple for loop and do it. But then we are not doing data science, right? We should be doing using NumPy. So, and NumPy will be much faster. So what I'll do is I have this list. Okay, I have this particular list. What I'll do is I'll say, okay, prices is equal to, you know what? It is equal to this list over here. It's a 2D list, everybody. Just to remind you all that if I look at prices, it's a 2D list. And if I just do prices.shape, what will I get? I'll get, sorry, shape is an attribute, not a, oh, not even that. It's a 2D list right now, actually. It's just a 2D list at this point. I need to convert it to an NumPy array. So I'll say prices is equal to np.array prices. So let me convert it to a NumPy array. Oh, what happened here? Yeah, converted that. And now if I do prices, I'll end up getting that 2D array, but it's a NumPy array. And NumPy will also do this. It will convert it to like a scientific notation. If I just do prices.shape, I have 291 days worth of data, 291 days of prices, and there are 2 columns. 2 columns are there. What are the 2 columns? One is the date, the timestamp, and the other one is the price. Now we don't really care about the timestamp. So what we need to do, we need to remove the timestamp and get only the prices. We need to extract the prices. How do we do that, everybody? We just saw how to take just the column. Axis is the mean. We'll do the mean. You can also just do that. You can just take the mean along that. That's also fine. But if I just want the prices, how do I do it? Very good. Prices, colon, comma, 1. Very nice. If I did this, I will get only and only the prices, right? So I'll further do prices is equal to this, and then 1 second. Now I got all the prices, right? All right. So now I'll get all the prices. If I just look at this, I have all of the prices with me, right? And if I do prices dot shape, I should ideally have 291. That's it. No columns with it. Okay. If I want to find the mean of the prices, what do I do? Prices dot mean. Okay. If I want to find the median, NP and dot median prices. If I want to find the standard deviation, NP dot STD prices. And if I want to find the max of this, you can do NP dot max. You can also just do prices dot max. You can also do prices dot min to get the minimum one over here. Okay. If I run this, I'll get that the mean price in this entire duration was 23,86,000. That was the price of 1 Bitcoin. The median price was 23,20,000. Okay. This is the standard deviation, right? So the standard deviation was 6,94,000. So if you bought the Bitcoin, it could have gone up almost 7 lakhs or down 7 lakhs, right? That's the standard deviation. Meaning if you had bought at the average price of 24 lakhs, it would have gone up to 30 lakhs or it could have gone down to, like on average, that's the fluctuation you can see. The maximum price that it reached was 36 lakhs, almost 35 lakhs something. And the minimum price it reached was 14 lakhs or roughly 15 lakhs what it reached. Okay. This is our desired price analysis. Okay. The entire cryptocurrency price analysis. Okay. Now, what you are going to do is, I'm going to put you all onto this one. Okay. This cohort, you'll all get to see it. There's a lot of reference material here and you can watch all of that, but I just want to show you the actual project. The mini project for today. Then tomorrow you'll have something related to pandas. It will be even more trickier. Let's see what's happening. So my suggestion will be, make sure that you are first doing everything line by line on a notebook. Which notebook? Python notebook or Jupyter notebook. If you want to do in your own local notebook also you can do, but try to focus on like Python notebook, like Jupyter notebook or the Colab notebook. One of them you do it so you get an idea step by step what is happening. It's much easier to debug also. Much easier to debug as well. Okay. Let's see. What's the issue here? Yeah. Okay. So this is the this is the actual project. All right. You basically have to, what you will be given is, you will be given the ID of the cryptocurrency. Okay. So you'll be given the ID of the cryptocurrency. In this case, it's Bitcoin. It could be anything else, right? Ethereum, Litecoin, anything. You'll be given the starting date of the date range. You'll be given the ending date of date range. And they're telling you, use this API, the one that we used already, to find the mean, median, minimum, maximum, and standard deviation, which is what we end up finding, right? So, for example, this will be something like of the input given to you. Bitcoin 2020-8-17, basically 17 August 2020 up till 19 December 2020. Okay, you're supposed to find out what was the mean, median, minimum price, max price, and standard deviation. Remember, all of these are in integers. So whatever value you get, convert it to integer. Don't round it, convert it to integer. Okay. So that is there. How will you do it? Step by step process is, first things first, construct that URL. First construct that URL. To construct the URL, actually even going back. Okay, so let's go step by step. You can note this down also. First step would be to take input. First step would be to take input. Input here is name of the cryptocurrency, right, which is like Bitcoin. then start date and end date. Now both start date and end date are in human readable form. They are not in Unix timestamp. So you'll construct the URL, but when you construct the URL, what will happen? You'll need Unix timestamps. So before constructing URL, you'll need to create Unix timestamps of the given date. So get the Unix timestamps of the date. Once you've got the Unix timestamp, plug that into the URL, do the request.get, take the URL, take the data, take the JSON of that data, you will get the prices. Take the prices list. The prices list will have how many columns? Prices list are how many columns? 2 columns, right? We'll have 2 columns. Do we want the first column? No, that's just the timestamps. We want the second column, which is prices. Take the second column into a NumPy array and get the mean, get the median, get the min price, max price, standard deviation. Okay, these are all the things that you will need to do. Okay, all right, you can actually get started. So that's what it is. You'll get, I'll just add you to this cohort, but meanwhile you can actually just get started on your notebooks, on your Python notebooks or whatever. I'll just add you to the cohort. So any doubts, any questions you can ask, any part you didn't understand, I'll repeat it. The space is yours. Yes. Very good. How to generate the Unix timestamp, right? Very nice. So this is the part I wanted you all to figure out. Okay. So try to figure out, Google it using Python, how to generate the Unix timestamp. Okay. If you're not able to, I'll show it to you tomorrow anyways. But these are the things you need to figure out, right? So when you do data science and when you do these things, APIs will have a lot of things that you need to change the format of yours to conform to satisfy their data. That's part of being a data scientist. So try understanding how to solve it. You can Google this. If you're not able to, I'll share how it's done. Okay. If you're not able to, I'll share how it's done. But Google it for now, how to convert given date time string into timestamp. One thing you can assume, it's a good question. One thing you can assume is the date given to you, the time is 00 only. It is at midnight. Okay. Midnight at UTC. 12 a.m. 12 a.m. Okay. You don't need to worry about converting it to some other time zone and so on. Take UTC time zone only. UTC means GMT, means London time. Okay. Take that time zone only. All right. I'll just add you to this cohort meanwhile.